Good morning. I'm on site here at Embedded World 2023, and joining me today is Chris Gammell, Developer Relations Lead, and Mike Stitch, Developer Relations Engineer at Golioth. Great to have you both today.
Thanks for having us here.
So we're going to be talking about the Internet of Things and Golioth's reference designs that they're showcasing here at the show. So could you start by giving us a brief introduction to yourselves?
Sure. My name's Chris Gammell. I've been doing hardware for about 20 years. Joined Golioth about a year and a half ago, but we're a small startup. We've been helping people connect their hardware to the internet. And we have a range of things that we hope to talk about here today, not just reference designs, but kind of the platform behind it. And we're excited about all of the different ecosystems that we support.
My name is Mike Stitch. I was at Hackaday as editor-in-chief for almost a decade and moved over to Golioth at the beginning of last year to work with Chris to build some really awesome reference designs. And I think we're doing the Internet of Things at the microcontroller level in a really unique way, and that made me excited to join up.
Okay, excellent. Well, that kind of segues into our next question. Could you give us a brief overview of Golioth?
Sure. So Golioth is a cloud that helps an instant cloud for your hardware for IoT. So if you think about, especially at the microcontroller level, like Mike mentioned, it's really difficult to do all of the things that you might want to do with a piece of hardware out in the world when it's just a small ARM device or RISC-V device, and there's not a ton of memory and overhead and a full scheduler like in Linux. So when you want to have that device still communicating back, still be power efficient, still do all the features that your customers want, then you need a platform like Golioth that not only supports you with SDKs, which is a big value proposition that we have, but also then understands the type of hardware that is out in the world, measuring sensors, doing low-level things, and making it really efficient to send that data back to the network. What did I miss, Mike?
No, I think you really got it. I really think of the Internet of Things as a sensor collecting data and sending it back. And it's easy to understand that way, but it gets really complicated when you move that to 100, 1,000, or 10,000 devices. You start to realize some really interesting edge cases, especially when it comes to control and upgrade of those devices. Yeah. And if you're a company starting out building something like that, you shouldn't have to solve the same problems over and over again. You should specialize on what your company does best and use a company like Golioth to facilitate that.
Yeah, one of the things we talk about is Golioth kind of helps you to avoid hiring your first two or three cloud engineers, right? So you think about you're putting this thing out in the world and you don't want to have to go and build all this web infrastructure just to get a log device back from it or to send an OTA update to the device out in the field. And that's stuff that we've already built for you and that you can hook into with our dev plan. First 50 devices are free and you can just get started right away.
Okay, well, I was going to ask what you could explain about reference design and how they are looking to help those looking to design an IoT device.
Sure. Yeah. So reference designs kind of started out with like a dog fooding mentality, right? So we need to test our own platform and we need to showcase that all of the things that we say we can do, we can actually do. So we're basically building kind of, I'd say 80% of the way to a product. We do it with things like development boards, so they're easily sourceable still, but we package them up into a thing that we'll show you here. And we target different industries because we also think that people don't approach building their product by saying, they don't start on day one with what chipset should I buy? They start with, well, how can I find out information around this area? So I'm in the ag tech sector and I want to monitor the soil moisture out in the field somewhere. Well, I start from there. I don't start with what chip do I start with? So they want to just have some way to begin their process and start to prove out a concept. Then they dive into the chipsets. Then they dive into the stuff below it. So we try and kind of fast forward them to that 80% point of their prototype, the proof of concept, and then they can prove out their idea and move it towards deployment.
And it seems like customers are asking for the same things over and over again, a general set of the same things. That's what the reference designs point at. And with a company like Digi-Key available, we can give a reference design to our customer. They can go out and buy 3 or 4 different components, get it shipped overnight or the next day, use the firmware from our reference designs and be up and running. So let's say this is a cold chain asset tracker. So it puts a dot on the map and it associates a temperature at a moment in time with that dot on the map. And inside is a Nordic NRF 9160. There's a Bosch BME 280 and a U-Blox GNSS, the GPS or GLONASS or Baidu satellite tracker on it. All of these are available, bill of materials from Digi-Key, and you can have that dot on the map tomorrow if you wanted to.
Well, you touched on IoT device for soil moisture monitor. I was wondering what assistance is this expected to bring?
Yeah, so if we actually make a cellular-based version of that, but really another thing that we showcase is that Golioth can work across different. So we have SDKs that support different vendors, such as our partners like Nordic, Infineon, NXP, Espressif. But you can start to move across technology areas too. It's very unlikely that you would have an Ethernet-based module out in the field. It's a long wire to run it out to a field to measure soil moisture. But you could do that. You could run on Thread, Wi-Fi, all these different technologies that's out there. And so again, we're just trying to highlight that the need to take a measurement somewhere in the real world. You can then switch technology, switch chipsets underneath the hood. We support all that kind of stuff. In terms of what that's actually used for, well, Mike lives out in a more remote area. I live in a more remote area now. People that we know that are in the agriculture industry, they want to have more data about their fields, their operations, and they want to save water. Obviously, water out in the West where there's been drought conditions. You want to definitely have precise agriculture applications there. And so the soil moisture reference design, which we don't have at the booth with us today, it is basically there as a starting point, right? So you can start to measure small stuff, you can prove out the idea, and then you could later take that and scale it up using Golioth, multiple devices out in your deployment.
Okay. Well, what is the kind of hardware and firmware and software that is involved with this device?
Yeah, so like that one, really all of these are kind of built around the same kind of base assets. So a lot of these devices we have with us today are cellular because we knew we were coming to a conference where we wanted to make sure that we had connectivity, never really rely on Wi-Fi when there's this many people around. So we always do cellular here. Same with the soil moisture, asset tracker, the trash can monitor, the power monitor, the air quality monitor, all these ones that we brought with us are all like that.
I think a core, though, to our business is that we're coming to you. You shouldn't have to change the type of hardware that you're using in your designs in order to use the Internet of Things. And so Golioth works on a ton of different platforms. We have set these reference designs up. So if you want to start with cellular, you want to move to Ethernet, you want to use Wi-Fi, those will all work with these designs. With us today, I think I mentioned before, is the Nordic NRF 9160, which is really popular. It is a cellular modem with GPS built in. And then on these reference designs, we have an adapter board that uses the microelectronic click boards. There are just a ton of those available. So let's say you needed a GPS device, but you weren't tracking temperature, you were tracking some other value. You can pop off that temperature, pressure, humidity sensor and pop on a different sensor, make a small change for the code so that you're actually getting the data in the right format and everything. Otherwise, everything else stays the same. And so I think this concept of being in a data-driven society where people need those inputs, we need to figure out on the hardware realm, how do we make sure that you don't spend 6 months in the doldrums working that stuff out? You should be able to this week have your proof of concept up and then refine it from there.
And Mike mentioned on the firmware side as well. So we're using the NRF 9160. We are part of the Zephyr project. We're actually showcasing at the Zephyr booth, which is 4-170 here at Embedded World, in case people see that. Zephyr is a real-time operating system that's open source. It is across different vendors. There's a lot of contributions from members throughout the community. And we're able to retarget not just the sensors, like Mike said, but the different hardware platforms, different vendors, different technology types. And so we like it because it really allows you to get a wide spread of coverage when you are in that decision-making phase and that proof of concept phase.
Okay, great. Well, obviously, a soil moisture monitor, we can expect it's going to monitor the moisture of the soil, but what other data can users expect to gain from this?
Sure. Actually, air quality monitor is probably another good one. Yeah. So this is another one we have. So we have these all kind of like mounted on shiny boards. Hopefully it shows up on camera okay. But this is basically, you might use this in an office environment, a home environment. Say you want to just monitor during wildfire conditions, similar like that. So particulate monitor from Sensirion on the bottom here. So this one brings in temperature, humidity, pressure, CO2, particulate sizes of 2.5, 10 micron, I believe. And basically, you can kind of track this stuff over time. What we're not showing in the laptop because it's a little hard to show here, and we might be able to show it in post, is once the data is coming from this cellular device up to the Golioth cloud, it's then accessible to other things. So you might be able to export it to your web team, right? So you might push it out to an AWS SQS, which is a queuing service. You might push it out to a GCP in data ingester or an Azure data ingester. Another thing that showcases is that the Golioth capabilities is we're helping you to talk to and interface with your hardware, control firmware updates, things like that. But once the data is actually captured, then it's easy to export it out to these kind of web native things. A lot of traditional solutions start from the web native, and they say like, oh well, I want to talk to the cellular device, but I want to do it over HTTPS. Well, that is not it's not power efficient, it's not data efficient, and you have to pay for data for cellular plans, things like that. And really, it's not the most speedy way of doing things, right? So Golioth is that interface layer down to your hardware, allows you to interface with the hardware and then pull that stuff back up to the cloud. Once it's in the cloud, then talking cloud to cloud, it's much easier, and you can start to do interesting things with it, send it to your data team, process data like that. And each of those individual data points that we talked about, soil moisture, air quality monitor, all of them are able to be kind of, other things can happen with them, right? Most data scientists only care about data. They don't care about how you get that data to the cloud. So.
Okay, well, I understand, for instance, the soil moisture monitor works in companion to the greenhouse controller reference design. Can you explain how they work together?
Well, so that was an interesting one that we built for the greenhouse controller. If you think about growing plants, keeping them at the right temperature, keeping them at the right humidity, you can monitor the temperature, and then that had mains rated relays, so you could open ventilation or run fans based on it. We were working on that in the late fall. Actually, I live in Wisconsin. It can be kind of cold there in the winter. I woke up one morning and I sat up in bed and I was like, it is too cold in this room.
Something's wrong. Yeah.
And my furnace wasn't running. Well, played around with it a little bit. It was the thermostat had broken. And I was like, what am I going to do here? It's the weekend. I had this greenhouse monitor we were working on. I connected it up to the furnace and I flipped a greater than sign to a less than sign because you want to keep the house warm and not cool.
That's right, yeah.
And actually ran my house off of Golioth, using the cloud to set the temperature. But I think really the point is, like remotely, if you have a house or a business where you need to monitor and make sure that the temperature is right for your employees or your pipes aren't freezing in the winter, having that data come in real time with Golioth. We talked about analyzing it. Sure, you can do that after the fact. You can also watch trending temperatures and you can say, okay, it's getting a little bit low. It's getting towards freezing in my house. Maybe I should send someone a text message and have them go out and look at it. And I think that that's a big enabler in society. We have up here a power monitor. So this started off as an AC power monitor. If you think about a manufacturing plant where you're going to have tools that are running off electricity, you might want to see like how frequently are these tools being used? Do I need to get another one because it's a bottleneck in my processing, or are they going out of spec? Am I going to need to get this service so it doesn't break down and have downtime? Of course, we can't really show that off at a conference here. So we took the same platform and we changed it to a DC power monitor. This would be really useful for things like if you had a kiosk of electric bikes, those bikes charge when they're parked, and you can monitor that charging and you can actually tell the health of the battery based on how that charging process goes. And so we're able to, right now we're just running a fan that's got some LEDs. It's nice at a booth, but we can see how much power is that LED fan consuming. And it's granular to the point where when it displays different parts of the LEDs, it's using a different amount of electricity. And we can see that, if you want to turn this around, we're graphing it live. It's coming in through the cellular data. And then as Chris turns on a light bulb here, we should see the second channel should jump a little bit in there. If we give it a second, there we go. So all of a sudden we have some auto scaling on the graph. So the graph is showing just kind of an off, not really working. Turn the light bulb on and it jumps. You can easily extrapolate this to whatever need you have. Everything runs on electricity these days.
So what was it that inspired this power monitor design?
I think it's just need from customers.
Yeah, a lot of, that's how we're driven by a lot of this stuff. I don't know, like where do ideas come from, Kristian?
Well, yeah, I think a really popular one in the consumer space right now is like being able to monitor each circuit in your home and what's taking up electricity. Do I have something plugged in that's actually using power and I didn't know? once you have that data coming in, you can see it on your phone. You're like, what is that? I'm going to go find that. And so even in testing, when we first demoed this, I opened up the circuit panel on my house and put some clamps on it.
Very careful.
Watched my refrigerator turn on and off, and my toaster oven, and the vacuum cleaner. And you just never think about those things. You use them, but you don't really know, like, from moment to moment, how much power am I using? And I think the more that people can think about that and be empowered to act on that, we can really make a change in what we do from day to day.
I'm sure at Specifier and at Digi-Key too, like we see lots of applications, right? I mean, like where else do you see applications in the space that need IoT? I'm sure there's other stuff out there, right?
Oh yeah, plenty. Maybe too much for this talk, maybe.
I got all day.
Well, maybe if you could just also give us a rundown of the sort of hardware and the firmware and the software as well. I'm sure people will be interested to know.
Sure. Yeah. So Mike's mentioned a little bit here, but like on the so kind of like from the hardware up. So if you start at a sensor, so the sensors are kind of different for each of these application spaces. Not completely different. We kind of put the Bosch sensor tech BME 280 in a lot of our designs, but it's not all the designs. And so you start from the sensors, which are varied and talk up to the microcontroller. Microcontroller in this case is an NRF 9160. That's a dual Cortex M33 that has a cellular modem in it as well. So now you're kind of at the top of that network stack. That's then being programmed with Zephyr, which is the real-time operating system that then handles all of the kind of communication out to the network towers as well. Once it hits the towers and goes through to the Golioth servers, that's when kind of the Golioth software takes over. We use a protocol called CoAP to talk to the various devices. And then at that point, your data, say you're just taking a temperature reading from here all the way up through up to the cloud. Now you're basically, you see in the cloud, 23C happened at 9:28 a.m. in Nuremberg. And then you can start to process that out to the rest of your cloud. And so then your web software takes over. It might be Python, it might be JavaScript, whatever.
We often talk about like what's going to make you look good to your customer or what's going to make you look good to your boss. And so you can choose any sensor that you want and make it work with the Golioth system. But can you get a sensor working tomorrow for that big meeting? And right. I think, again, with Digi-Key, we will have, okay, we got a meeting coming up next week. We go on Digi-Key, what do they have that they can ship us? Does that work with our platform? You can almost always find something that's going to get you up and running the next day or the next week. Once you have that proof of concept, you show someone, you come and hand someone, here, look, it's putting your dot on the map. Like Chris said earlier, they don't really care what the specific sensor is. That's a manufacturing problem. I think the point is, will it work? Like, does this concept?
Does it sell your idea?
Exactly.
Does it get you the funding you need? Does it get you to the sale? That's what we start to think about.
Okay. Well, also I'd like to mention that is the IoT monitor that helps monitor trash cans how filled they're up. We had a lot of fun about that in the office. It was great.
Yeah.
So just wanted to maybe if you could give us a rundown how this would work.
Sure. So we had a couple of different customers coming to us asking about this sort of thing. When you start to think about energy efficiency and just regular logistical boring problems that IoT kind of helps to solve, an IoT trash can is a great example here. So you're in a national park, you have trash cans far afield throughout that national park, but you do have cell service. Not every national park does. You want to maybe send back data from that. How full is the trash can? When do I need to send out trucks? Can I help to schedule those trucks, that truck schedule so that I save on the diesel to send a many ton piece of equipment up there to go and just check a trash can. So instead you send data back over the cell network. You can have other things in there. So this one has a couple different sensors in it. It has a distance time of flight sensor from ST. It has the BME 280 for just environmental monitoring, because it's always good to kind of chuck one of those in there. It has a VOC sensor in there. So if you imagine, say it's now not in a national park, but a city construct. Well, you want to know if there's been illegal dumping. Maybe someone's dumped paint into your trash can. You can also monitor that sort of thing. So VOC is put off from paint. And so then it sends that data back. And then you can start to do things like monitor across not just one, but now you have a fleet of devices. So you have 100 different these trash cans. You could start to then ingest that data from Golioth and say, okay, I've now created a new route for trash truck 23 to go from point A to point L to point P, and skipping all the other ones in between to save money there. I actually know of a company that's doing this, and not only, so they're actually an operations company. They have an IoT concept to their business, but they're an operations company. And then they were even able to get green credits from the fact that they are saving emissions in the process of going to pick up trash in an everyday context.
I have to think about festival goers too. If you see the trash situation at a festival, when there's enough trash cans and they're not overflowing, people are a lot better at getting the trash into the can and keeping it clean. And so if you have a limited number of staff to service those and you're keeping those at a manageable level, you probably are saving a lot of labor in picking up trash around the festival later on. I think we can all get behind that idea.
Yeah, certainly. You talked about the sensors that it uses to measure what's inside, how full it is. Could you tell us briefly about the connectivity? Because of course you're talking about things that are far out in the wilderness, really.
Sure. Yeah, I mean, so all of these are cellular-based modems, Cat M1 or NB-IoT. There's dual mode on the part that we're using. Depending on what your needs are, right? So a national park might not have cell coverage. You could switch to other types of connectivity there, satellite, LoRa, similar types of things. Most of the time, we are targeting cellular first, and then moving on from there. When we are using cellular, there's a wide range of NVNOs out there, MNOs out there. So that's kind of the SIM providers, kind of the way to think about that. We buy our SIMs off of Digi-Key as well, of course.
I think an interesting application in that we had a friend that was wondering what the coverage was going to be like for cellular network. And so built a module that would go and test signal strength or lack of signal strength and kind of cache that data. And when the network came back in, upload it along with GPS data. And then you end up with, where am I going to have a reliable signal? Where am I not going to have a reliable signal? Just by driving around for a few days with the device.
Okay. There's perhaps also, as we've asked for the other ones, maybe you could give us a rundown of the old hardware, the firmware, the software of this, the old trash can sensor.
Oh, sure. So from the ground up again, NRF 9160, firmware is Zephyr. And then, network software is kind of the easy way to think about that is Golioth. In terms of the sensors on board, VL53OX. Is that right?
A1.
Oh, yeah.
L01.
L01, that's right. And BME 280 and a CCS 811.
And I think one of the interesting things on this, if you think about this, so this gets epoxied on the other underside of the trash can lid, and it points down and it bounces off of the trash, so you can tell the level.
Really measuring this distance here. So the bigger the distance is, the lower the trash is.
But if you think about that, you would have to assume that every trash can has the same distance in order to get the right level back. And so what Chris did when he was designing this one is he actually made it so that once you install it on the cloud side of things, you can tell it what the different levels should be. So, if you have 80 centimeters that you're measuring, that is, 20% full. Or if you have 40 centimeters, it's 50% full. And so even after these are out in the field, if you look at it, you're like, that data is not coming quite right. You can look it up and be like, what trash can did we install that on, and change the settings, even though you don't have physical access to this anymore.
Right. So that's a Golioth side service that we have called the setting service. We have other things like remote procedure calls, where we can actually do remote execution of different ideas that we program onto here. So things like setting the log level. So you might want to say how verbose this thing is, sending back logging messages. It might be debug messages. It might just be errors. It might just be warnings.
This is a Sensorion sensor for particulates, and it's got a fan inside of there. And if you have a particularly heavy day, like Chris mentioned, forest fires, you're going to end up having particles stuck in there, and it needs to go through a cleaning process. So like when you have an out of spec day, how do you clean that? Do you send someone out to do that? With Golioth, you can actually just go onto the web console, pick this device off of your list and say, hey, run an additional cleaning cycle, and let's see if the data is actually reading how it should.
Okay, excellent. You talked about open source projects that you have. I was wondering if you could expand on that. What is it that you look for in a partner, and how does your partner benefit your customers?
Yeah, so we base all of our device SDKs. So what's actually running on these is based on open source software. So our software developer kit itself is open source. And then what we're running on here, the Zephyr project, is open source, and it is run, managed by the Linux Foundation. And so what this means is you have the ability to look in the code and make sure that the code meets your coding standards and does what you want. You also have the ability to crack it open and add new things to it in a way that makes the most sense to your company, or partner with someone else in the ecosystem to build those up and contribute those back. And it really means that your limited engineering resources get multiplied, 1,000-fold by the number of contributors, the number of different companies that are buying in. The other thing that I really like is the Zephyr project goes out and works with the silicon manufacturers. So those manufacturers are directly supporting their own projects. So you know that the equipment is being used in the way that the manufacturer recommends. And they obviously have a lot of benefit to giving you the newest, latest, greatest working software.
In terms of our partnerships, all of our silicon partners are also members of or not all members, but they all are contributing to the Zephyr project. There's members and then contributors. And we find that helps us to really have a shared goal of providing open source firmware out to our users, their users, and kind of help them get the stuff in the world faster.
Golioth uses the Apache 2 license. And so if your company has a software license you're wondering about, ours is very permissive and it will work with your program.
Okay, excellent. Well, it's been a fascinating talk today. The hardware that we've discussed, is that on display at the show?
That's right. Yeah. So we're at booth 4-170, which is the Zephyr booth. We're there. We're sharing time with the other members that are there, but we'll be there this afternoon and then again tomorrow. So Wednesday afternoon, Thursday morning.
Okay. So, well, that was great. It was a pleasure speaking to you.
Thanks for talking about it.
And thank you for your insights. Enjoy the rest of the show.
Thank you.